Hey everyone, welcome back to day 28 of my 30 days of JavaScript LeetCode challenge. Today's problem is one of the most practical JavaScript design interview question, implementing your own emitter system. This is the core concept behind Node.js, events and browser event listener. Let's see the question explanation. The problem asks us to design an EventEmitter class that supports two operations: subscribe and emit. Subscribe registers a callback for an event name, returns an object with an unsubscribed method, invokes all callbacks associated with the event name, returns an array of results from each callback. An event can have multiple listeners and they must run in the order they were subscribed. You can go through the examples. There are 4 examples. And now let's see the thought process. To implement this cleanly, we will store all listeners inside an object. Subscribe, emit. Subscribe, create the list if it does not exist, and the callback to the list. Return an unsubscribe function that removes that specific callback. And emit function is no listener. If no listener exists, returns an empty array. Otherwise, call each callback with callback. Collect the return values. Make sure to use a copy of the listener list during emission so removing listener does not break iteration. Let's see the code right now. First, we start by defining a class called EventEmitter. This is the blueprint for the object that will manage all our events and listeners. Inside the constructor, we create a property called events and set it to an empty object. This object will act like a map from event names to an array of listener functions. So, for example, it can look like first event square bracket cb1 comma cb2, second event square bracket cb3. The subscribe method. Now let's see the subscribe method. Next, we define the subscribe method. It takes 2 arguments, event name and callback. Event name, the name of the event we want to listen to, the function we want to run when that event is emitted. Here we check if we already have an array of listeners for this event name. If not, we create a new empty array. This makes sure this .events is always an array before we start adding listeners. Now we store that array in a local variable called listeners. This is just a shorter, more readable way of refer to the same array for the rest of the function. And then we push the callback into the listeners array. This means that the next time this event is emitted, this callback will be one of the functions that gets called. According to the problem, subscribe should return an object that has an unsubscribed method. So here we start returning that object. Inside the returned object, we define an unsubscribe function. This is an arrow function and it closes over listeners and callback. That means it remembers which callback to remove later. Then first we find the position of this callback in the listeners array using indexOf. If the callback exists in the array, we use splice to remove exactly one element at that index. This effectively unsubscribes that callback from the event. After removing the callback, if there is no listeners left for this event, we clean up by deleting that event key from the event object. This step is optional but keeps our data structured and clean. This and is an unsubscribe function and the object we return from subscribe. So whenever someone calls unsubscribe, this specific callback will be removed from the event. Now let's see the emit method. It takes an event name and an optional array. That this array will be passed to every callback associated with that event, and we default args to an empty array if nothing is provided. Here we look up all the listeners that are registered for this event name. If nobody subscribed to this event, listeners will be undefined. If there are no listeners or the array is empty, we immediately return an empty array because there is nothing to call and nothing to collect. We create an empty array called results. This will store the return value of each callback that we invoke. Now we loop over each callback in the listeners array. Notice that we use listeners. We are creating a shallow copy of the array. This is important because a callback might unsubscribe itself while we are still emitting, and modifying the original array during iteration can cause bugs. Using a copy keeps the loop stable. For each callback, we call it with the spread function. Whatever value the callback returns, we push that into the results array. This way we can collect all return value in the order of subscription. After we finish looping through all listeners, we return the result array, and that's our complete event emitter class. It supports subscribing, unsubscribing, and emitting events with arguments, and it returns all results in a clean array. And that wraps up day 28. This problem teaches objects design, closure, and how event systems actually work behind the scene. If you are enjoying the series, make sure to like the video and subscribe to Code and Click so you will never miss the next challenge. See you in the day 29. Thank you everyone.